Okay, let's finish off the review doing some application problems. Okay, so remember when you're doing this, what you need to do is familiarize yourself with the problem. Look at any formulas, anything like that that you need. Identify your variables. What do they want to know? And then you want to translate it into an equation. And these are going to be quadratic, so keep that in mind when you're doing that. Then you're going to solve it. You're going to check your answer then, both to see if it makes sense to the problem and that it is mathematically correct. And then you're done. Okay, so it says the product of two consecutive positive odd integers is 195. Find the numbers. Okay, product means we're going to multiply. Two consecutive positive, okay, that's going to be key. Positive odd integers is 195. So two positive odd integers are going to be x and x plus 2. And then, of course, is, and 195 is 195. Okay, so I'm going to multiply these. X times x plus 2 is equal, whoops, and I forgot my 5, is 195. Okay. All right, so let's think about our steps now when we want to solve this. This is not equal to 0, so we have to take care of that. So this becomes x times x plus 2 minus 195 is equal to 0. Okay, so now I'm going to have to factor this, but that means I have to distribute. So x squared plus 2x minus 195 is equal to 0. Okay, so now I need to find two numbers whose product is negative 195 and whose sum is 2. Okay, so I've got 1 and 195. It's not divisible by 2. So let me get to my calculator here just a second. Okay, so it is divisible by 3. It's divisible by 5. Let's see what else. I think it isn't divisible by anything else until 15. So 13 times 15, and that's it. Okay, so since it's positive, that means that the smaller one has to be negative. So I have negative 1 plus 195 isn't 2. Negative 3 plus 195 does not equal 2. Negative 5 plus 39 does not equal 2. Negative 13 plus 15, there's my winner. Okay, so this factors now into x minus 13 times x plus 15 equals 0. Set each equal to 0. X minus 13 is 0. X plus 15 is 0. So here x equals 13, and here x equals negative 15. That's where the positive comes in. This cannot be a solution to the problem. It's a solution to the equation, but not to the problem. So x is 13. So if x equals 13, then x plus 2 is equal to 15. So the numbers are 13 and 15. Okay, the length of a garden is twice the width. If the area of the garden is 98 square feet, find the dimensions. Okay, so I've got my garden, and I know the area of the garden is 98 square feet, and it tells me one of these is the width and one of them is the length. Well, I don't know how to do this with two variables, but it tells me here that the length of the garden is twice the width. So this is going to be 2W. Now I know that the length times the width is equal to the area. So 2W times W is equal to 98. That gives me 2W to the second is 98. Okay, so this is not equal to 0. I'm ready to solve now. So I have to write this as 2W to the second minus 98 is equal to 0. So, like always, when I'm factoring, I want to look for a greatest common factor. Both of these are even numbers, so I can factor out a 2. So I have 2 times W to the second minus 49 is equal to 0. Okay. Two terms, since I've already factored out the greatest common factor, the only thing I can do now is a difference of squares. Okay. So this is W to the second minus 40, or I'm sorry, and 49 is 7 to the second. So this becomes W plus 7 times W minus 7, and the whole thing is equal to 0, and I want to include the 2. Okay, well, now I can set up that 2 equals 0, W plus 7 equals 0, or W minus 7 equals 0. 2 can never equal 0. Here, this gives me W equals negative 7. Your dimensions cannot be negative. Here, W equals 7, so there's my width. And then my length is equal to 2W, which is 2 times 7, which is 14. So the dimensions, are 7 feet by 14 feet. And 7 times 14 is 98. Okay, John's mailbox number is 6 more than mine. The product of the numbers is 55. So product means I'm going to multiply. And it's going to equal 55. Okay, well, I don't know anything about John's mailbox, but I do know it in relationship to mine. So I'm going to let X equal mine. And then John is going to be mine plus 6. So I'm going to take X times X plus 6, that's the product of them, is 55. Okay, so this is just like problem 58. It's not equal to 0. So I'm going to have to write it as X times X plus 6 minus 55 is equal to 0. Okay, so I still need to turn it into two factors. So I will distribute. So I get X squared plus 6X minus 55 is 0. No greatest common factor, 3 terms, leading coefficient is 1. So I'm looking for two numbers whose product is negative 55 and whose sum is 6. Well, the factors of 55 are 1 and 55 and 5 times 11. One of them has to be negative, and since the sum is positive, that means the smaller one has to be negative. So if I change this to plus, negative 1 plus 55 does not equal 6. Negative 5 plus 11 equals 6. So these are my numbers. Negative 5 and 11, negative 5 and 11. So this factors into X minus 5, X plus 11, is equal to 0. Okay, so if the product equals 0, then x minus 5 equals 0, or x plus 11 is equal to 0. Here, this tells me that x is 5. Here, that tells me x is equal to negative 11. Well, the mailbox number is not going to be negative, so it's an answer to the equation, but not to the situation. So x equals 5, and then x plus 6 is equal to 5 plus 6, which is 11. So my mailbox is number 5, and John's is 11. Okay, 2 more problems, then we're done. Alrighty, so a rectangle is 40 feet wide. The diagonal of the rectangle is 41. What is the length? Okay, so we've got a rectangle. And it tells me that the width is 40 and the diagonal is 41. So what is the length? Well, what I've got here is a right triangle, so I'm going to have to use the Pythagorean theorem. Which says a squared plus b squared is equal to c squared, where a and b are the legs and c is the hypotenuse. So I know that 40 squared plus L squared is equal to 41 squared. So 40 squared is 1600 plus L squared is equal to 1681. Okay, it's not equal to 0. So I'm going to subtract 1681 from both sides. So I get negative 81 plus L squared is equal to 0. Now this is kind of close to what I want, but I want to put this in descending order. So I get L squared minus 81 is 0, and now I see that this is a difference of squares. So this is L to the second minus 9 to the second equals 0. So it factors into L plus 9 times L minus 9. So if L is equal, let me go back up here. I was running out of room and trying to do something else. Okay, so if L plus 9 equals 0, then L equals negative 9. Can't have a dimension of a negative number. If L minus 9 equals 0, L equals 9. So the length is 9, and that's in feet. Okay, and our final problem of the review, the lengths of the sides of a right triangle, okay, so I'm going to draw a right triangle, are 15 and 20. What is the length of the hypotenuse? This is what they want to know. Okay. So following the Pythagorean theorem, I know the sum of the square of the legs is equal to the square of the hypotenuse. So 15 squared plus 20 squared is equal to x squared. And that's the length that I'm looking for. 15 squared is 225. 20 squared is 400. So 625 is equal to x squared. Okay. It's not equal to 0. So I'm going to move it over here. So I have 0 is equal to x squared minus 625. Now I'm hoping that's a perfect square. So if I take the square root of 625, I get 25. Okay, so 0 is equal to x squared minus 25 squared. So this becomes x plus 25 times x minus 25. X plus 25 is 0. X minus 25 is 0. Here x equals negative 25. Can't have a negative dimension. Here you have x equals 25. So the hypotenuse is 25 inches. The end. Okay, so I hope this was helpful. See you next time.